Hello, welcome back to the third video on data structures and algorithm. In this video, we are going to discuss about stacks basics, stacks using C++, the implementation using C++ and big O notation. Stacks introduction. Stack is also one of the data structures. Stack is a set of memory location used to implement LIFO or FILO. LIFO is basically last in first out and FILO is basically first in last out. Okay, see both are same. LIFO and FILO is both are same. So if you take a real time example and you have some set of 5 books, okay, you wanted to keep the books in a piled way. What you do is first book you keep it at the bottom and the last book will be on the top. If you want to take the first book, it will happen at the last only, and the last book whatever you have placed under the pile you will be taking at the first position. So the concept is explained here. If you keep on pressing the first book, you place the first book here, on the top of the first book you keep second book, on the top of that third one, fourth one and fifth one, like this. So if you want to take the first one, it will not happen immediately. You need to take the fifth one, fourth one, third one, second one and the first one. So whatever you have placed at the bottom, that is the first, whatever you have placed it at the first instance will come only at the last one. Okay. Similarly, if you take a woman putting bangles and first bangle whatever you put, it will go at the last. Okay. If you want to take out, always the last bangle whatever you put, that will be coming at the first position. Okay. So this is basically the concept of LIFO or FILO. Okay. The same concept is used in stacks. Same concept is used in stacks here. So let us go to this Word file. Okay, let me explain you what is happening here in this. Okay, so if you have 5 books here, so what will happen here? First you take this one and place it here. This is the first book. On top of this one you take the second book and place it here. Okay, and third one, if you place, you will be place it, you can place it on the top of the second one, and same way fourth one you are going to place it on the top of fourth one, and fifth one you are going to place it here. So your stack will be starting from the bottom till the top here. Okay, and the fifth book is the one which you have placed at the last. Only that one you will take it out first. So fourth one before this fifth one, so you will take the second way you take it, and third one is the third place you will take it here, and then second one you take it here, and the first one you placed it at the first instance. So you are going to take this book only at the last. So this is actually called as first in last out or last in first out. Okay. So now let us go to the concept here. So stacks introduction, we can implement the following operations on the stack. One is push. So push is basically you are placing an item inside the stack and there is no place, then the stack is overflow. It is in the overflow state. So you have actually, since we are implementing this stacks by using an array, it is having a limited set of locations. Like for example, if I have an array of 5 elements and I have only 5 elements I can put it inside, and the beyond the fifth one I cannot put inside that. So that's why if you have 5 elements and you have already placed all the 5 elements within that particular stack, and when there is a sixth element coming here, there will not be any place for holding that particular element. So that is a state which is called as stack overflow state. Okay, pop is nothing but it will always take the top element here. So it's basically what you are going to do is you are going to take the item from the stack and remove from the stack itself. Okay, you will take the fifth element, at the same time you are also removing the element from the stack. So if there are no items in the stack, then it is called as empty stack, or it is called as empty state. It is also called as stack underflow state. Okay, so push and pop are very important operations which we are going to do it on the stack operation. Whenever you add any element to the stack, it is called as push, and whenever you are taking out the element from the stack, it is called as pop. Okay, and pop will always act on the last element whatever you have placed it in the stack. Peek is another function which we are going to implement it. Basically based on the, it is similar to search, but based on the position sent you can get the value here. So we are going to implement in an array, we are going to implement stacks using an array. So you will be sending the position to what to seek or what to peek into that. If I send the third element, then you will get the third element from that one. So it is basically similar to search function here. The next is change an element in a particular location. So if I want to change the third element, then you can change it by using this change function here. We are going to implement all these functions along with these 3 functions also. These 3 functions will support all these 4 functions to execute. Okay, there is a function called as isEmpty, there is a function called as isFull, and this is a display function, and display function is going to display all the elements of the stack, and isFull, it is going to find out whether the stack is full or not, and isEmpty is going to find out whether the stack is empty or not. Okay, now let us go to the next one. In this session we will implement the stacks by using arrays. We have already seen arrays previously in the previous videos. It is basically a series of memory location starting from 0 to 4 in case of 5 elements in an array. Okay, and the array elements can be accessed by using the name and the index number. Okay, so since we are implementing the stacks by using array, the first element of an array will be the 0th element of the array. The first element in the stack will be the 0th element in the array here, and the last element will be the 4th element. Okay, when you have an array of 5 elements here. Okay, so along with this implementation, we are also going to maintain one integer value which is nothing but top, and this top is nothing but it will always maintain the current index of an array. Okay, current position of an array here. So this top will play a very important role in the implementation of the stacks. So let us create a let us implement this stacks now. Okay, so first for the implementation, let us create a class called a stack here, and you have 2 private members here, and these 2 private member, one is going to be the top, which I have already mentioned in the previous slide, which says that it will always keep track of the number of entries in the stack here. Okay, and basically this is an array. Under this particular array only the stack is going to get implemented. So there are 2 private members, array stack of 5 elements in the array, and it is going to be an integer array, and you have a top variable that is going to maintain the track of the number of entries. At the same time, it is also going to maintain the position of the index position of an array here. Okay. So how it is used and how it is, we are going to use this top to do the push and pop operation, we will see that now. Okay. And we are going to write different methods here under the public. We will see what are the methods which we are going to write it. Now first, if you look at a stack here, stack is an array. We are using array to implement stack here, and we have sorry, we have an array of 5 elements here, and we have 5 elements 1 2 3 4 5, and as we know that index position will always start from 0, and it will go 1 2 3 4 like that, and since it is going to be a 5 element, it will go from 0 to 5. Okay. So what we are going to do is, whenever I declare an array, let us initialize the array here by storing values 0 in all these things, because it is an integer array. So we are going to store zeros in all the elements of that one. And there is one more variable called as top. That top is always going to maintain certain value, that is the index value of that one. Suppose assume that one value has been stored under the tags under the stack, so it will always have the index position 0 inside that. Okay. But now it is going to be a new array and new stack here, and no elements are available here. So our top value, let us put -1. Okay. 1 less than this 0, so you are going to put -1 here. So how I am going to initialize this array? How will I put the top value there? What I am going to do is, I am going to create a constructor stack. Okay. Under that stack, I am going to put top is equal to -1, and I am going to have a for loop for I is equal to 0, I is less than 5, I plus plus, and the entire elements, all the elements within that particular array is going to made it as 0 here. So for initializing the stack, I am going to use this constructor, and constructor, you already know about the constructors when you are writing a C++ code, and if you are having a class, and you can write a constructor, and that constructor is basically a function which is going to have the same name as the class itself. Okay. So let us see when we are implementing this one using a C++ code, we will see about that. Next is isEmpty function. Okay. See, when as I have told you already in the previous in this slide, we have 5 elements in an array, and this array is going to be initialized to 0 here. All the elements are going to be 0 here, no values are available inside this particular stack. So you put top is equal to minus here. So you have made top is as -1 here when the array is empty. So if you wanted to check if the stack is empty, then you can write a function called as isEmpty function. Okay. And it is going to return a boolean value. Okay. And within that particular function, we can check if the top is equal to -1, then return true, else return false. So top is not going to be -1 when some values are put inside this, and top is going to be -1 when there are no values within this particular thing. Okay. So now we are going to write a function called as empty, isEmpty function, which is having a boolean value. A boolean value will be returned back from this function here, and if top is equal to -1, then you return true, else return false. So isEmpty function will be like this. Next is, we have written an empty function here. IsFull, how do you say that the stack is going to be full here? So what is going to happen here? I am going to write a logic, an algorithm like this. Top is going to be -1 when there are no values. When I am putting the 0th value, that is the first value, when I put it, top, I am going to say top is equal to top plus 1. which is going to be 0. Okay, minus 1 plus 1 will become 0. So you are entering the value of the first element. Similarly, when I am entering the second value, I will add 1 to the top, then go to the number 1 element here, and again I will add one more, then I will go to the second value, I will add one more, I will go to the third value, I will add one more, and I will go to the fourth value. And after 4 there are no other location available to you here, because we are using arrays. Okay, so when the top value is equal to 4, then it is full, the stack is full. The stack will be full when top is equal to 4 here. So you can write a boolean function, we can write a function called as is full, and it will return a bool value. Okay, in within this is full function, if top is equal to 4, you will say return true, else return false. So this is going to be is full function. Stack implementation, the next implementation we are going to see about the push. Now we have already seen about how to write is empty and how to write is full. Okay, and push is basically what we are going to add elements to the stack. Adding elements to the stack is done when the stack is not full. When the stack is not full, only we can enter it. If it is full, we cannot enter any value within the stack. So what we are doing is, we are going to say push this value. That means you have to send the value what you wanted to push it to that stack. So that's why I am having a function which takes a value, one parameter it takes, which is nothing but val. Okay, so this val is going to be pushed inside the stack. So the push function is going to have, if first I will check whether the push is full or, if the stack is full or not. If is full function we have already returned here. Okay, this is going to check if top is equal to 4, then it will return 4, it will return true. Then this when it returns true, that means stack is full. That means you have written all the elements within that stack and you don't have any place to have a push now. Okay, or you don't have any place to add any elements to that. Okay, in case if it is not full, then you go to the else part. Okay, and you say top plus plus, you add 1 to the top, that means you will increase 1 to the minus 1, whatever you have it in the top, minus 1 you have plus 1, you do it. So what is going to happen here, it is going to come to 0th position, and in the 0th position you are adding this value here. Okay, so push is going to happen here. Whenever you try to push it, it will first you are going to check whether it is going to be full or not, the stack is full or not. If stack is not full, when the stack is not full, then only you add the element to the stack. Okay, so this is about the push function. Next is pop function. Pop is basically what we have seen about pop. Pop is a method which is going to take the element from the top position and then remove that particular element from that particular stack. Okay, so basically if I am going to have if I have 5 elements here, and it is going to be the last element which is available on the top. Okay, so what I am doing is, whenever I say pop, this element is going to be taken out. This element is going to be taken out. It is going to be made as 0 here. Okay, and then the top will be pointing to this. Okay, so that is what we are going to do it in pop, integer pop. If it is empty, stack is empty, you cannot do any pop. Okay, then you return any value, return a 0 here. Okay, so pop will always return the last element, whatever it is gone into the stack, it will take the value outside and it will give you that particular value to you, and it will also make you make that particular element as 0 here. So what is that is the reason that I have put integer here and you have pop function. Okay, this does not take any value within this one. So, if it is empty, then stack is going to be empty and you will return 0. So, there are no elements there in the stack. So, that is why you are putting 0 here. Else if it is not empty, what you will do is, first you take the element on the top position, that is array stack top, you take it and you put that in one of the temporary variable return value you have. I have a integer variable called as return value. Okay, so that value I am going to put it here and you make that element as 0 here and then you decrement that top minus minus. So, what is happening here, when there is a suppose assume that you have only one element here, that means your top will become is equal to 0 now. Okay, top is equal to 0 now and you wanted to take this element out, means you wanted to pop out that 0th element. So, you are taking out this particular 0th element and returning back to the user and you are making this top as -1. So, it becomes it is not pointing anywhere else and you also make this particular element as 0 here, the contents of that particular element as 0 here. So, that is what is happening here. Integer return value, first I am taking the value and putting it in a temporary variable and I am making that particular location, that element as 0 here and making this top as minus and return that value whatever I have taken from that last element. So, this is about the pop. Next is count. I wanted to see the count of this one. So, what is going to be the count? How many elements are there in that in the stack here? So, this is going to return a value integer and we will be calling this count function. You have CNT, you declare a temporary variable called as CNT. CNT is equal to top plus 1. Okay, so top is basically it will be pointing to the element, the last element whatever it has been entered. You will add 1 to that and return back that particular count into the to the user here. Okay, so count function will return the number of elements in the stack. And similarly peek I said it is equal to the search function. So, what I am doing in the peek is I wanted to take the value of this value of the value which is present in the position, like as example in the third position what is the value. So, the value whatever I am going to search in that particular stack is going to be returned back by using this integer and I am going to pass position to that. So, if whenever you are trying to peek or whenever you are trying to search, okay, first you will have to check whether this particular stack is going to be empty or not. If it is not empty, then only you can return back the value. If it is empty, then you will return 0 here. Okay, so you are searching for element in this first, I mean the position. So, you will return array stack of position, whatever your position you give it here and that position is returned back into this place. Next is we are going to implement change and we need to change the value at a particular position. Okay, so the change is a function which is going to take two parameters, one is position and the value. Okay, so what you will do is inside this function you are going to say array stack of position, that is going to be the position which you want to change it and what value you want to change it, that value is equal to that particular value. So, the item value has been changed in this position, that is what is the message which I am going to give it in the change one and it is does not return any value here. Then displaying is displaying an array. So, displaying an array is very simple. So, you will be displaying from top to bottom 0 to 5 in case of fifth location, 0 to 4 in case of 5 elements in an array, but here in the stack you wanted to display from bottom to top, that is like fourth element first and then go to third element, second element, first element and zeroth element. So that's why your for loop is starting from I is equal to 4, I is greater than or equal to 0 and I minus minus, and I am going to display this values one line by line. Okay. These are all the functions which will come inside the class. Okay. And after that you will have to write the main function here. So to demonstrate the stack, what you will do is, first I will declare an object of the stack S1. Okay. So I am going to push values here. So how we have defined our push here? Push is taking one value and that value is going to be pushed to this particular stack. Okay. And that will be pushed inside this particular stack when it is not full only. So like for example, in this main function I am going to push value 1. So it will go to the 0th location of the array, and similarly push 2, 3, 4, 5. 5 elements you have pushed it here, and you are calling a display function, and this display function is going to display all the elements in the reverse order, that is from the 4th to 0. Okay. And when you try to push the 6th element, so S1 dot push 0, push of 6 here, what is going to happen here? It is going to give an error message saying that stack is full. Okay. Now popping the element from the stack, how do you do that one? S1 dot pop. Okay. Here I am not giving any value passed to the pop function, because always it will pop up the last element only. Okay, that we have seen in the implementation of the pop function only, pop function itself. So the value on the top position is going to be S1 dot pop, because S1 dot pop is going to return an integer value, and that is going to be displayed on the screen. Next is, after popping up, we need to see about the count. We will see about the count here, and the count is going to be the number of it is going to show me, say for example, if I have the 5 elements in the stack and I have already popped up one of the values there, so your count will be 4. So it is going to give you the exact count of the count of elements in the stack here. So I am calling this count function here in the main function here. Similarly, if you want to change the value, so I want to change the third position value as 10 here. So what is going to happen here? It is going to change whatever is there in the third element, it is going to change it as 10, and I am calling this display function to display the value on the screen. So it will show the changed value there. Okay. So peeping is in the third position. So I want to see what is the value in the third position. So I will say peak of 3, S1 dot peak of 3 here. So what is going to happen here in the third position? What is the value that is going to be displayed here in this cout function? So this function let us implement in the C++ code, and we will see how it is going to, we will run the C code and see how it is going to work for us. Okay. So I will take this class, whatever we have discussed here in this one, as a reference, and I will write it. Okay. And we have already seen that we will be writing in IDE1 function, IDE1. So this is actually an URL where you will be writing your code, and you can compile this code either by using different languages. Okay. So we are writing C++ code. I have selected C++ here. So let me write a function here. Let me start writing the class stack. So in this class stack, I am going to have two private members. One is integer top, the other one is going to be the stack. So I am going to say array stack. This is going to have 5 elements. So there is an array called as ARR stack, which is having 5 elements. Okay. and this is going to be used for implementing the stack operations. Now we will go to the public functions. So what is the first one we have discussed? We wanted to initialize the top, at the same time we wanted to initialize the array stack. Okay. So for that we are using the constructor. So constructor will have the is basically a function which is similar, which is having the similar name as stack here. So a similar name as a class. So I say stack. Okay, class will have to have a semicolon at the end of this one. So stack, and this function is a function, and this is going to be a constructor because it is having the same name as a class here. So you will not have any, even the return value will not be there, even void you cannot put here, we cannot declare as void, and you can have parameters, but this parameter I am not using it here because it is a default constructor. Okay. So what I am going to do here is in the stack is, first I am going to make top is equal to -1, and then later for integer I is equal to 0, I is less than 5, I plus plus. So within this for loop what I am going to do is, I am going to say arr stack of I is equal to 0 here. That means all the elements I am going to make it as 0 here. This is initialization, and this is going to be top is equal to -1. So I am starting from -1, I will go to 0, I will go to 1, 2, 3, 4, like that it goes on. So the first initialization will be first will be our constructor, that is a default constructor I have written here, and the default constructor is going to initialize top value. At the same time it is also going to initialize the for loop. Using the for loop it is also going to initialize the array. So next function is going to be is empty. So is empty is a function which is going to return boolean type. So I will say bool, okay, is empty. Okay, and in this function it is going to return a value here on certain condition. So what is the condition which we are going to see here? So the condition is, if top is equal to -1, that means no value is added to the stack. Okay, so if top is equal to -1, then return true, that means it is empty, else return false. So I am writing a empty function like this. So the empty function is going to be like if top is -1, then return true, else it is going to be return false. Then we saw about is full. So I am going to write the full function, bool is full. So here also I am going to write the full function like this, if top is equal to 4, then return true, else return false. So this is going to be the is full function. Okay. Next is boolean, and now we will go for push. We have seen about these things. Class we have declared, and we have declared the constructor, and we have seen about is function, we have seen about full function, and now we are going to write push. Okay. So how the push will be written? So it will be a void function push, and I am going to say integer val. So push will accept one variable, okay, as a parameter, and that parameter whatever you are going to pass is going to be pushed to the location, the latest location. So here in this condition we are going to check if if is empty, sorry, is full. When I am going to push it, when it is not full only, I will be pushing into the stack. So if it is not full, I will, if it is full, then I will say C out stack overflow. Okay. So what is going to happen here, when it is full here, when the stack is going to be full, it will say that stack is overflowing, and then it will come out of this particular function. Else what I will do is first I have to make top plus plus, okay, then I need to enter ARR, that array stack is there, no, array stack of top is equal to val. So what I am doing here, I am just incrementing the top value, and then I am going to put that array stack on the top. Array stack top is equal to val. Whatever value I have taken it as a parameter here, that value will come to the array stack here. So now what we have written is, we have written is empty function, we have written a constructor is empty function, is full function, and is push function. Now let us go for pop. So pop is going to do what? It is going to take the last, whatever last entry which has come to the stack, that particular value it will take it and give it to us. At the same time it will also delete it. So in this case, the deletion, what I am doing is, I am just making that particular element as 0, okay, and returning back whatever value which was there in the previous previously whatever was there in that particular place. So there should be a return value from this function pop, and it does not take any value here, because it is going to take, always give you the last element only. So this is going to be the pop function, and this function, when it will pop up, when it is not empty only. So in case of push, when it is full here, it cannot do a push, but in case of pop, when it is an empty, it cannot do an pop. Okay. So if, so same way here also, if is empty, so if it is empty here, what I will do is, I will say C out stack is empty, it cannot pop, okay, or I will say stack is under overflow, underflow. So if it is not an empty here, I will go to the else part. In this else part, what I will do is, I am going to write a function like this. I am going to write this one, these statements. So I will declare a temporary variable. This is going to be return value, and that is equal to whatever value which is available on the, in the last element which has gone inside the stack. So which is going to be ARR stack of top. Next, what I am going to do is ARR stack top is equal to 0. So whatever value it was there in this top element, I have stored in the return value, and I am making that particular element as 0. Then I am making this top as minus minus. Okay. So this is what we have seen here in the pop. Okay. So and the last value, last one will is going to be whatever value you have taken it from the top, that is going to be returned back. So you will say return ret val. Okay. So this is what is going to be the pop function, and this pop function is going to have if it is empty, it cannot return any value, but if it is not empty, you will take the top element and return that top element, and in between you are going to delete that element. By doing this equal to 0, I am deleting it, and whenever I say top minus minus, it becomes the value again goes back to the next element in the stack. So pop is going to do like this. And similarly, what is the next function we are going to implement? Count. So integer count, and this is going to just return the value, how much value is available there. So I am going to say integer cnt, cnt is equal to top plus 1, and then I will say return cnt. Okay. So this is going to return me how many elements are there in currently, how many elements are available under this stack. Next is going to be peak. So if it is empty, then stack is going to be empty here, otherwise you are going to return this value. So here we are going to take the position, which position you want to return, and the return value is integer value here. So it is going to be integer peak, integer position. So if the stack is empty, if is empty, then I will say stack is empty. See out. Okay. Else, if that is not there, return array stack of position. So this is going to be our peak function here, which is written here, which we have explained here in this one. Next function is going to be change. Okay, the change function is going to take position and value. Okay, so position will be taking from that particular position, this value is going to be changed. So this position in the array is going to be changing the value, whatever new value we are giving it here. Then we are going to give a message. So I am going to write change. So it doesn't return any value, so it is going to be void change, and inside this I am going to take integer position and integer val. So this function is going to change new value in the position whatever we have sending it. So arr stack of pos is equal to new value whatever you have sent. Okay, then I am going to display cout. See, in the position, in the value has been changed in the position. In the position pos, and then endl. Okay, so this will be displayed after changing the value here. So next is the display function. So the display function is going to be like this: void display, and again it doesn't return take any value here. So this display function is going to display for integer I is equal to, I am going to start from 4 because it is an array of 5 elements. So 0 to 4. Okay, I is greater than or equal to 0 and I plus plus, and within this I am going to display this cout arr stack of I. Then go to end of line every time when you display here. So this is going to be our for loop for this display function. Okay, this is going to be I minus minus because we are starting from 4. Okay, so our display function will be there. So till now we have written all the methods. So if you look at the stack class, you have two private variables and we have written function public functions below that. Okay, there is a constructor which is going to initialize the value of each and every element of the stack. Okay, and the boolean, it is going to return whether it is empty or not by checking the top value, and by using checking the top value we are going to return whether it is full or not by using this isFull function. And there is a push function which is going to take a value as a parameter, and that parameter value will be put under the top value under the top position of an array ARR stack. That value is going to be put here, and if it is full then it is going to say that you cannot push any value because stack is overflowing. Okay, and pop is going to be, if it is empty you cannot pop anything, so it is going to have an underflow, otherwise it is going to return the value and it is going to delete the value from the stack. Okay, so this is going to be pop function and you are going to return the count, and this is going to be your peak value. Peak is nothing but you are searching for this one. In this position whatever value is there you are returning it back, ARR stack position. So what is going to happen here, in this position whatever value is there that is going to be returned back, and change is nothing but in this position you change this value. So you change this value in this array stack, you change it to val here. Okay, display is again displaying the values on the screen here. So these functions we have written in the stack class. Okay, now let us go to the main program. So in this main program I will declare stack s1. So s1 is an object of stack class. Stack class, there is a class called a stack, and this stack I am declaring an object of the stack class here. So s1 dot, first let us add some elements here. Okay, but before going to the adding the elements here by using the push, whenever I say s stack s1 you are declaring an object. Whenever you are declaring an object, default constructor will be called, and this default constructor it will make the top as -1 and it will initialize the entire array here, because you have an array here we are initializing that array. So that is happening whenever I declare an object. So now after initializing the array and then making the top as -1, I am going to say push, I will say 1. That means I am pushing 1 to the last element. Okay, I am keep on adding it here, s1 dot push. I know it is only 5 elements, so I am going to write only 5 push here. So s1 dot push 3. So s1 dot push 4, s1 dot push 5. So only 5 elements are there, so I have written 5 push here. Okay, and after this all the pushes I am going to display the values on the screen. So s1 dot display. Okay, so this display function is going to execute this one. So let us execute this code and see. First we are initializing the array, we are initializing the stack here. Okay, and initializing the stack. Okay, and top to -1. Okay, that we are doing it when I am declaring an object, because it is going to call the constructor, and I am calling this push 5 times here because 5 values I am going to push it to the stack here, I am displaying it here. So let us see how it is executing first these statements. You can use this run to run the application. So at the end if you look at this one, it is going to run it here. There is some problem here in this one. Forbidden stack has no type. So you have stack, sorry, spelling mistake. You edit it here and then go and change it, stack. So this is one error which we got it by mistake, we have written that. Then stack, okay, I think that is the error. Okay, save this and again IDE1 it. And before going to that one, let us clear all the things, compilation error. Okay, now let us run this application. So now it is running now. So what has happened here? It has pushed all the values. So that means it has pushed 1, 2, 3, 4, 5. So but it is displaying from 5, 4, 3, 2, 1. This is going to be the top element now. That is last element which has come inside the stack is 5. The first element which has gone inside is going to be 1. Okay. So whenever you pop up, always the last one will come out. Always the last one will come out here. So fifth one will come out here in this case. Okay. So when you say pop, 5 will become 0 and you will see that value returned back is going to be 5. Okay. So next what I am going to do is just to check, I am going to have one more push. Already 5 elements has been pushed here. So now the stack is full. So let us see whether that is returning back to me or not. Okay, I am adding s1 dot push 6. 5 elements are over. I have displayed it also. Now again I am going to run this one. So now I am trying to add one extra element to the stack. If it is full, it should say stack is full. So let us see the output. So now you see that 5 elements you are able to add it and you are able to display the value here on the screen by using this s1 dot display. But when I am trying to add the 6th element, it says stack is full, overflow. That means it is full, stack is full. Okay. So in our statements we have done up to this point. Okay. Now I want to take the pop value. So let us use pop. How do you pop it? Okay, s1 dot pop. So this is going to return me always the last element, that is in this 5, 4, 3, 2, 1. It is going to take 5 and it is going to display the value for me. And then it is going to make this 5 also as 5, that position as 0 here. Okay. So how do you do that one? I am going to put this pop in a cout statement. Cout the value, the top value or last value, okay, top value in the stack is equal to this one. Okay. So I am going to display the top value by using the pop. Okay, because this pop is going to return me the last value. It should display 5 for me in this particular cout statement, and I am going to use this display function now. So when I am calling this display function, it has to display the entire what do you say, the stack here, the values in the stack. In that, the last one, that is whatever I entered last in the stack, that should become 0 and other values should be displayed here. So let me clear the output and I am saving it and running the application. So when I am compiling, first time what is going to happen here, it is going to display this 5, 4, 3, 2, 1 and the stack is overflow. That has happened up to this point. Okay, and the top value on the stack is going to be 5, and after that it is going to display the stack values. The first element, I mean that the top element 5 has been removed and it has been made it as 0 here. The remaining elements are available to you as it is. Okay, so now let us go for the count. So you have popped out one of the things. So that means you have 1, 2, 3, 4, 5 element, and this 5 element you have removed one element in that one. So your count should be only 4. So let us use the count function here for displaying the count after this. Okay, so this pop will be there, and you are going to say count of cout. I am going to say now the count is after pop. Now the count is okay. So there is a function called as count here, s1 dot count. Okay, so now you have that count function here. No, there is a function called as count. So that is what I am calling here. This is going to give me the count of the number of elements in the stack. So let me clear this output. I will save this and then run it. So when I am running it, you can see that 5432 first time I have loaded all the full 4 things. I am trying to add the 6th one. It says stack overflow, and the top value whatever is available in that the stack is going to be 5 only, the top one. And after the top one, after removing the top one, you can see that the values is going to be 1 2 3 4, and you have 0 at the top, and after pop the count is going to become 4 here. So the count, it has reduced, 1 has been reduced here in this case. Okay, so that is about the count. And now next go to the change. So I wanted to change the third element to 10, and let us see what is going to be the value here. Okay, so change, I am going to use change now, s1 dot change, and the position will be 3, and I am going to make it as 10 here. So the value in the third position is going to be 10, and then I am going to use s1 dot display. So what is going to happen here in this case, I am going to do all the things from the beginning. I am going to put 5 elements, display that, trying to put the 6th value, it will show stack overflow, and then I am going to pop one element from that. Okay, and displaying the value, displaying the entire stack after popping up, and after popping up I am also seeing the count. Okay, and after seeing the count I am changing the value, so I am using the change function there. Okay, so now let me run this one, you see the output. So these things we have already seen many times. Okay, after 4 you do this one. So the value to be changed in the position is 3. Third position we have changed the value. That means you see that 0 1 2 3 it has changed to 10, and the last element is going to be 0 here. Okay, so change is working like this. When I am passing the position and the value to be changed, the value has been changed here when I am doing the display function. Next is peaking. What is the value which is available under the third position? So that can be found by using the peak function, cout. The value in third position is, what I will do is s1 dot peak, and you have to pass 3 to that. Okay, 3 as a parameter, and then you say endl. Okay, so now let us clear the output, save that, and run the application here. So when I am running the application here, you can see the initial outputs, say 5 to 1 to 5. Stack overflow is also displaying here, and top value is top value is going to be 5, and that is been popped out. So you have 1 to 4 only here, and the last element is going to be 0. After popping out, the count is 4. The value has been changed to the third position, that is going to be 10, and the third position value is going to be 10 here. So 0 1 2 3, so it is going to display me 10 here in this case. So in this example we have seen about all the push, pop, all the operations whatever we have discussed in the stack. Okay. So here just to this is just to explain the concepts here. So all the validations, many of the validations I have not taken care here, but the concept is explained in full for the stack by using this example. And since every time when I am running it here it executes from the beginning, I want that to happen here because it is all in array. In the random access memory it is going to be stored. So the values will not be available permanently for us, it is going to be temporarily here. So that's why I am running it every time, so that it is executing from the beginning, and then you are able to see all the push, pop, count, we have seen change, display, and then peak, we are able to do it. And within that push and pop we are also used our is empty or is full. Okay. So this is our code for stack implementation using a C++ code. Okay. So now let us go back to the slides. So we have done this implementation now using C++. Hope you have understood this one. You try to implement the same thing using your laptop. Okay, and if you have any clarifications you can put it in the slides, you can put it in the comments. Okay. So now big O notation. See here the big O notation is not going to have much changes here, because the stacks are implemented by using arrays only. So here the stacks are implemented using arrays, so our big O notation would not have much changes. Okay, let us see what is that. Okay, we have implemented all the functions and methods. So if you look at the push method, it is equivalent to store. When you say peek, it is equivalent to search. Pop is nothing but it is equivalent to delete. Okay, and the insert, there is no insert concept in the stacks here, because always the push will push it on the top only, it is not going to push it at in between any of the values here in the stack here. So there is no insert concept here, so we will not have insert for our big O notation in the stacks. So it is going to be very similar to our arrays only. So when I am trying to do a store, okay, you are going to do push. So for every element to be pushed, you need one operation. So for n element to be pushed, you need n operations here. So it is going to be O of n. And similarly searching we have used only peek here, where we have sent only the parameter, the position we have sent it and you have taken it. But in case you wanted to search in an array, as we have discussed in the array sessions, when I am searching for the first element it is going to be one operation, when it is going to be at the last it is going to be n operations. So here also the search is going to be same, because we are implemented stack by using arrays. So here the search is also going to be O of n. So insert concept is not there, so I am not going to deal about this insert right now in this stacks. Now delete, again delete, when I am trying to delete one operation, one delete if I have to do, I have to do one pop. Okay, if I want to do 5 pops, if I am doing 5 pops, it is going to be 5 operations to be done. Okay, if I have to do 5 pops, I have to do 5 operations. So it is going to be O of n here. So your big O notation for stack is also going to be store is O of n, search is O of n, and delete is O of n only. Okay, so it is almost very similar to what we have done in the arrays here. So in the next video I am going to discuss about the queues, and queues also is going to be implemented by using arrays only. So in the next video when I am discussing on the queues, I am not going to discuss about the big O notation, because it is not going to have much changes in the big O notation when I am implementing the queues using an array. Okay, so after discussing about the linked list and the single linked list and double linked list, okay, then we can try to go for the big O notation for the comparison, and we can look at how the big O notation is going to be there. So, we will plan to put a case study on the big O notation after explaining about all the what do you say, all the data structures. Okay. So, in this video we have seen about the introduction about the stacks using a C++ example. Okay, stack implementation is done by using arrays, and big O notation would be similar to what we have seen in the arrays here. Okay, and thank you.